Okay, so long division is kind of difficult to do. It's not difficult, but here's another way that you could do it. So we're given the task to figure this out. In example number 3, they want us to take 2x cubed minus 3x squared minus 5x minus 12 and divide it by x minus 3. Now what I want you to do is I want you to look at this term here, the numerator. Is every power of x represented? Right? We have x to the third, x to the second, x to the first, and then our constant. Now, this is just like the remainder theorem. Okay? If we apply the remainder theorem, what we do with this here is we would say x minus 3 should equal 0 or x equals 3. So if this is a solution, then we would set this equal to 0 and we would, graphically speaking, we would cross the x-axis at x equals 3. Does that make sense? You guys remember all that stuff? All right. So then using that remainder theorem, we're just going to draw it a little differently. We're going to just write down the leading coefficients. Okay? We're just going to write down the leading coefficients. So, and I always like to write it like this. This is the x squared, this is the x to the 0. And so I've got negative 2x cubed, or not negative 2, positive 2, negative 3x squared, negative 5, and then negative 12. Now this is how this works. The first thing you do is drop down the 2. Okay? You just drop down the 2. Now, what is 3 times 2? So when you go from here to here, you multiply. Add those up. What is negative 3 plus 6? 3. Multiply 3 by 3, and what do you get? 9. Okay? Now, add those up. What do you get? 4. Multiply by 3, what do you get? 12. So now here, this is saying that my remainder is 0, because that last column is always the remainder. Now, when we divide x cubed by x, what do you expect this to be? 2x squared, everything drops down a power, plus 3x plus 4. So for synthetic division, we can find out how, we could divide this number or this polynomial by this binomial, and we'll get this as an answer. So now, just to kind of show you guys where that comes from, let's actually write it out longhand. So if I do 2x cubed minus 3x squared minus 5x minus 12. And then I have divided by x minus 3. Now, if I divide this by x, in other words, what do I multiply x by to get 2x cubed? 2x squared. So, automatically, because we're dividing by x, that leading coefficient is always going to be the leading coefficient of the quotient. Does that make sense? Because this is always going to have x to the first. If it doesn't, or not x to the first, if it's not 1x, in other words, let's say we had 2x minus 3, then we've got to do something different. But all of your problems are going to be rigged, x minus 3, x plus 2, x minus 7, whatever. Since the leading coefficient of the binomial is 1, we're always going to have to multiply that by the leading coefficient of the dividend. Does that make sense? So that's why in this synthetic division, we always drop the first number down. When I subtract, so if I multiply that through, I'm going to get 6, negative 6x squared, and then 2x cubed. Then when I reverse the sign, what do? I'm going to subtract this, and I'm going to add this. Now it's no accident. What am I adding here? I'm adding 6. So I have negative 3x squared plus 6x. What do I have in my x squared column? Negative 3 and 6. So those cancel, and what am I left with? 3. That's no accident. So now what do I multiply this by to get this? Well, this becomes 3x squared, and then I drop down my 5x. And so what do I multiply x by to get 3x squared? 3x. So I add 3x. When I multiply that through, I get 3x times negative 3, which is negative 9x. And then I get 3x squared. When I change the sign, I'm left with a positive 9x and a 5x in the x column. Negative 5 and 9, that's no accident. When I add them up, what do I get? A positive 4. That's no accident. Now what do I multiply this by to get a positive 4x? Well, I got to drop this down first. I multiply it by positive 4. When I multiply it through, I get 4x minus 12. When I change the sign, everything cancels. I have a remainder of 0. Okay? So synthetic division isn't any different than the long division. It's just faster and quicker because we don't write everything down. Does that make sense? Okay, good.